Hello everyone, today we're going to be going over the August 2025 Algebra 1 Regents exam. In this video we're going to be covering part 1, which are the first 24 multiple choice questions. A link to this test can be found in the description of this video if you want to follow along at home, alongside more videos that go over part 2, 3, and 4 of this test. So if you want a full review of this exam, check out those videos after you're done watching this one. That being said, we're going to go ahead and start off with number 1, which asks us which expression is equivalent to 100x squared minus 16. So to solve this problem, you just need to know that a squared minus b squared is equal to a plus b times a minus b, okay? So whenever you have two perfect squares like 100x squared and 16 and you're subtracting them, you can always rewrite them as their individual components being added to each other and subtracted to each other. So what I mean by this is 100x squared is the same thing as saying 10x raised to the power of 2. So 10x is going to become my a, okay, because 10x squared turns into 100x. Then 4 squared is the same thing as 16. So here I'm subtracting that from 4 squared. And I can rewrite this as 10 minus 4, or 10x minus 4 times 10x plus 4, which lines up with choice 3, right? Number 2 says Josie has $2.30 in dimes and quarters, and we know that she has 2 more dimes than quarters. Which equation below can be used to determine x, the number of quarters that she has, okay? So in this case, we know the total value of her coins. We know that the number of quarters that she has is equal to x, and the number of dimes that she has is equal to 2 plus x. So how did I figure that out? Well, I know by reading this, it's describing how many dimes she has because it's saying that she has dimes, okay? How many dimes does she have? Well, she has 2 more dimes, okay? 2 more means plus 2. If I want more of something, I'm going to add it. If I want 2 more of something, I'm going to add 2. Then, what does she have 2 more of? Well, if you just read the sentence, she has 2 more dimes. Sorry, she has 2 more dimes, right? That's how we know we're talking about dimes, than quarters. So we're adding that 2 plus to the to x, which is the number of quarters, okay? A trick that I like to do to never get confused about wording is I like to remove the math from the sentence. So remove the numbers. She has dimes, okay? Remove the 2 more. She has dimes means that you're going to write something that is equivalent to the number of dimes that she has, okay? So now we just have to combine these two equations together. Remember that the value of a coin is equal to the number of coins you have times the value of each coin. Okay, so she has x quarters. We know that quarters are equal to $0.25 or 25 cents. So 0.25x is the total value of all her quarters. And then you can add that to the total value of her dimes. A dime is worth $0.1 or 10 cents. And you're multiplying that by the total number of dimes, which is 2 plus x, okay? And this is equal to $2.30. That's what this 2.3 is representing here. So that's going to be choice 3. Number 3 says, if g of x is equal to negative 2x squared plus 16, then g of negative 3 equals what? Well, remember, whenever you have g of x and you're trying to solve for like g of 1 or g of 2, all you have to do is just replace x with the number inside the parentheses. So in this case, 1, 2, or in this problem, negative 3, okay? This works if you have f of x or h of x, any letter of x, whenever you're trying to solve for a number, like h of 1, h of 2, h of negative 3, replace the x with negative 3. A way that I like to remember this is, well, how did I go from g of x to g of negative 3? Oh, I replaced the x with negative 3. So we do the same thing here. Wherever you see an x, replace it with negative 3. Or plug in negative 3, okay? Same thing. So here I have negative 2 times x, which we know is negative 3, and it's x squared, so that's negative 3 squared, plus 16. You can plug this into your calculator, or you can do this by hand. At the end of the day, you get negative 2 as the answer, because you get negative 2 times 9, because negative 3 squared is 9, plus 16. Negative 2 times 9 is negative 18, plus 16 is equal to negative 2. All right, number 4 asks us what are the zeros of x squared minus 8x minus 20. Whenever you're solving for the zeros, you're just going to have to factor this out and set the two parentheses equal to 0. So if I have x squared minus 8x minus 20, and I'm factoring it out, I'm going to look for two numbers that can multiply into negative 20, but that add into negative 8, okay? And those two numbers are going to be negative 10 and 2. So negative 10 times 2 is negative 20, but negative 10 plus 2 is negative 8. The reason why I found those two numbers is so that I can split this up, this negative 8, into two numbers. So here, I can split it up into negative 10x plus 2x minus 20. So if I simplify this, I'd still get this equation up here. But the reason why I needed to split this negative 8 into two numbers is so that I can then split this into two parentheses, each with 2 numbers, right? It needs to be an even number for me to split it up. So now I can just factor out or find something that both sides of this have in common, now that I can evenly split this equation into a left and a right-hand side. So on the left-hand side, I'm going to take away x. So x goes into x squared, and x also goes into negative 10x once. So when I take it away, I get x minus 10. Over here, 2 goes into 2x and into negative 20. So if I divide 2 from, or take away 2 from both of these terms, I get 2 times x minus 10. Now I can combine both of these parentheses into 1, and I can combine both of these into 1. I'm left with x plus 2 times x minus 10, okay? Now finally, like I said at the start of this problem, I have to set both of these equal to 0. So x minus 10 is equal to 0, and x plus 2 is equal to 0. And whatever value of x makes both of these equal to 0, that's going to be the zeros. So in this case, 10 minus 10 is equal to 0, so 10 has to be a 0, and negative 2 plus 2 is equal to 0, so negative 2 has to be another 0. So that's going to be choice 2. If you didn't want to do all this math, you could have totally done it in your calculator. If you went ahead, pressed y equals, and did x squared minus 8x minus 20, hit graph, and you could have done second trace 0, and the calculator would have solved for the zeros as long as you give it a left bound, which is a point to the left of the 0, and right bound, which is a point to the right of the 0, okay? And when you hit guess, you should put the cursor on where you think the 0 is, which is somewhere around here, and it'll tell you that the 0 is at x equals negative 2. When you use this method, just be careful, because sometimes, like in this case, the graph isn't fully shown on the set of axes, so you can go zoom, and then you can scroll down to where it says zoom fit, and it'll automatically set the window so that you can see both zeros. So in this case, we can see the first one's around here, and the second one is all the way over there. And if I trace this with my cursor, this 0 is pretty much at negative 2, and this 0 is at 1, 2, 3, 4, 5, 6, 7, 8, 9, and 10. Pretty much crosses over the 10 right there. All right? Remember that the 0 is when the graph crosses over the x-axis, okay? It's the x value at the point where the graph crosses over the x-axis, or when the y is equal to 0. All right, number 5 asks us, which point lies on the graph of y is equal to 3x squared minus 1/4 x plus 3? So to solve this problem, we're just going to plug in the x values of all of these points, and we're going to see if the y values for these points match up with the y value of this equation, okay? So essentially, the whole point of an equation is it gives us a y output based on an x input. Each one of these coordinate planes are showing x inputs and y outputs, okay? But the issue is 3 of these choices are going to give us y outputs for different graphs. So the correct answer is going to give us the same y output for the same x input, okay? So the way we solve this is just we plug in all of the x inputs, and then we see which one matches with the y output. So, for example, if I have the equation y equals 3x squared minus 1/4 x plus 3, I'm going to plug in negative 2. So I'm going to go ahead and do 3 times, in parentheses, negative 2 squared minus 1/4 times, in parentheses, negative 2 plus 3. And that's going to give me 31/2. Now I can convert this into a decimal by pressing alpha, y equals, and then pressing 4, or scrolling down where it says f to d. This represents fraction to decimal. If I click enter, I know that my y output is 15.5. So when we input an x value of negative 2, this function gives us a y output of 15.5. Now guess what? That matches up with this point. So this has to lie on the graph because the graph outputs this point, okay? An example of an answer that wouldn't be correct is this. If I plugged in, so this point is saying that if I were to plug in negative 1 into this graph, it would output 5.75 as the answer. In reality, if I plugged in negative 1 for x here, this would give me an answer of about 6.5, right? That's a different point. That's an entirely different y output. So this cannot lie on the graph because the y outputs don't match, okay? Number 6 says, given f of x is equal to x squared and g of x is equal to 8x minus 15, and they're graphed on the same set of axes, which values of x will make f of x equal to g of x? So to solve this problem, we could just set both equations equal to each other, right? So if we have f of x, which is the same thing as saying x squared, and we're setting it equal to g of x, which is the same thing as saying 8x minus 15, look at that, we just set them equal to each other. So all we have to do is just solve for x. So again, wherever you see f of x, just replace it with whatever it's equal to. So f of x is the same thing as x squared, so just replace this with x squared. on the opposite side of the equal sign, replace g of x with 8x minus 15. Okay? And right here, now we have to solve for x. So how do we solve for x? Well, we make this whole thing equal to 0. So we move everything to one side. So to do that, I'm going to subtract both sides by 8x, and I'm going to be left with x squared minus 8x is equal to negative 15. And then I'm going to add 15 on both sides so that I can cancel out the 15 here, and I get x squared minus 8x plus 15 is equal to 0. Now that it's equal to 0, I can factor it out, and we already know how to do that, right? So I'm looking for two numbers that add into negative 8 but multiply to get us 15. And those two numbers are negative 3 times negative 5, okay? Negative 3 plus negative 5 is equal to negative 8. So I'm going to split this negative 8x into negative 3x and negative 5x. And now I can split my function up, or my equation, into a left and a right side. So I'm going to factor the left and the right. From here, I can only take out x, so I'm left with x minus 3. On this side, I'm going to factor out negative 5, and I'm going to be left with x minus 3. I'm going to combine both of these into one parentheses, which is x minus 3, and then I'm going to combine both of these into one parentheses, which is x, and then I'm going to slap on the minus 5, and now this is equal to 0. So we can see here that we have two parentheses. Whenever we're left with two parentheses, we want to set both of them equal to 0. So x minus 3 is equal to 0, and x minus 5 is equal to 0. Now 3 minus 3 is equal to 0, so 3 has to be a solution, and then 5 minus 5 is equal to 0, so 5 has to be a solution. And that's going to be choice 3. Now, let's say you didn't want to do all that math. What you could have done was you could have pressed y equals, and you could have graphed both of these functions. So you could have graphed x squared, and then 8x plus 15. Sorry, add 8x minus 15. So if you hit graph, it's kind of hard to tell where the two functions are. So you can press zoom, and then you can do zoom fit, okay? And that's going to readjust the zoom. And you can kind of see here how this graph touches the blue graph like twice, right? So you can go second, trace, and then you can find the intersect by scrolling down to intersect. And when it asks you for the first curve, select a point before where you think the intersection occurs. And then when it asks you for the second curve, select a point after the intersection occurs. And then when it asks you to guess, you can go ahead and put your cursor over where the intersection happened. You press enter, it'll tell you that the intersection's at x equals 3 and y equals 9. Now be careful, that does not mean that the answer is 3 and 9. When you look at the point of intersection, you're only going to look at the x value. So this 9 is not relevant. So x equals 3 is one of the points. Now remember, there's a second point that's kind of hidden that's also right here. So if you press trace, intersect, and you do the same thing, but this time you put your cursor closer to this intersection, it's going to give you the answer of x equals 5. So that's how we got 3 and 5. All right. So this is a way to do it without doing any sort of math. But if you needed to show your work, the first method is for sure the way to go. Now, this was a particularly challenging problem to do on the calculator because it's very hard to see that there's 2 points of intersection. So you can always hit second graph, and you can see which x value makes the y values equal, which means that the two graphs are equal at that point. So in this case, you can see that for sure 3 makes them equal to each other because they both are equal to 9 at that point, but 5 does the same thing. So a lot of students would have seen this graph and assumed that there's one intersection, but there's actually 2. And you could have always zoomed in on this graph to get a better look, okay? So you could have pressed zoomed in, and you could see that there's one intersection here and a second one there. Moving on to number 7, it asks which trinomial is written in standard form and has a constant term of 5. So the constant term of 5 means that you need the number 5 being added on to the end of the, or subtracted from the end of the expression. So in this case, we know that choice 1 and choice 3 are wrong because their constant terms are 10 and 1. So the constant term is whatever does not have an x attached to it. So that's 1 and 10 here. So we know that 2 and 4 are in the running because their constant term is 5. They have a 5 without an x attached to it. Now we have to look at which one's written in standard form. So standard form just means that the exponents are in decreasing order, going from biggest to smallest, which means that choice 4 is the right answer because we go from biggest, which is 5, to smallest, which is 2. This is not written in standard form because the biggest exponent is not the first term. Here it's the second term, right? All right, moving on to number 8. It asks, when solving x squared plus 6x is equal to negative 8, a student wrote x squared plus 6x plus 8 equals 0 as their first step. Which property justifies this step? So whenever I look at these problems, I want to figure out, or rather, I want to take inventory of what's on the left and the right side. So taking inventory, I'm going to notice what changed. So notice here how in our first equation, I have x squared on the first side, and in my second equation, I also have x squared on the first side. So that didn't change. Here I have plus 6x, here I have plus 6x, so that didn't change. But over here, I have no 8. So all of a sudden, in my second step, I gained an 8, or I got an 8 got added to this side. And if I look at this side of the equal sign, I lost this 8 in the second step. So how can you gain an 8 and lose an 8 at the same time? Well, the question is, she just moved the 8 onto this side, right? This side no longer has an 8, and this side gained an 8. So she had to move this 8 from one side to the other. How can you do that? Well, you can just add 8 on both sides, right? Negative 8 plus 8 cancels each other out to get 0, and then x squared plus 6x plus 8 turns into what you have left on the other side. So in this case, you just added 8 to both sides, okay? So take inventory of both sides, see what's missing, and then figure out how you can make that miss. So I was thinking, well, how can I cancel out negative 8 to get 0? And I thought, oh, I added 8. And then if I looked on this side, oh, look, there's that plus 8 that I did to get rid of the 8 on this side. So whenever you're adding two things over the equal sign, that's going to be the addition property of equality. As a matter of fact, whenever you hear of equality, that doesn't matter if it's addition, subtraction, division, or multiplication. Of equality means that it was done to both sides of the equation, okay? Or both sides of the equal sign. Number 9 asks, the tables below show the input and output for 4 different functions. Which table represents a linear function? So in a linear function, you're going to have the same rate of change for the y value, okay? So in this case, f of x, g of x, h of x, this is all the same thing as just saying y, okay? And in a linear function, this y value is going to change by the same amount. So the way that I like to solve these problems is I like to write out what happens to the y. Literally, I like to write, okay, so if I got from 6 to 1, what had to happen? I had to subtract 5. Then if I went from 1 to negative 2, I had to subtract 3. Then from negative 3 to negative 1, I subtracted 1. So I want you guys to do that for all of these tables. So if we look at the changes in the y, we can see that only j of x has the same change for every single step, okay? So to get to every single next y value, I decrease by 4, which means that my rate of change, literally the way that the speed at which the y changes, or the amount by which the y changes, is always the same. All of these other problems here, all of these other tables here had a different way in which the y changed. This one was inconsistent. We went from -5 to -3 to -1 to +1 to +3. Here, we went -1, and then all of a sudden we changed to +1. If the number isn't the same for every single hop, it's not linear. In this case, it was, so this one has to be linear. Number 10 asks us, what is the solution set to the equation 3x squared is equal to 24x? All we have to do here really is just verify which values of x makes both sides of these of the equation equal to each other. So they already gave us the possible solution sets here, so why don't we just plug it in and see which ones are correct? So if I plug in 8 to both sides, I have 3 times 16 is equal to 24 times 8, okay? Is that true? Well, 24 times 8 and 3 times 16, well, one of them is equal to 192. The other one is equal to 48. So is that a solution? No, because it doesn't. Oh, sorry. It's not times 16. It's times 64, guys. Because 8 squared is 64. Okay, so sorry. Is 3 times 64 going to give you that? Yeah. So this side was equal to 192. And this side is equal to 192. So 8 is a solution. Is it the only solution? No. So let's look at these other answer choices, okay? So just looking at this, we can eliminate choice 3 as a correct answer because it doesn't contain 8, which is a solution, okay? And remember, a solution is something that makes both sides equal to each other. So then choice 2 says that 0 is also a solution. So let's look at that. So if I plug in 0, I have 3 times 0 squared is equal to 24 times 0. 0 squared is 0, and 3 times 0 is 0. 24 times 0 is also 0. So yeah, both sides are equal to each other. So 0 is a solution for sure. So now I have to test whether or not negative 8 is a solution. And 3 times negative 8 squared is equal to 192. But 24 times negative 8 is equal to negative 192. So these two are not equal to each other. So negative 8 is not a solution. Moving on to number 11, it says the table below shows the radioactivity level of a substance after the time given t. What is the average rate of change in the radioactivity level over the interval 1 is less than or equal to t, which is less than or equal to 3. So essentially, it's asking you to find the average rate of change between the radioactivity level at 1 second and the radioactivity level at 3 seconds. So remember that the average rate of change is equal to the slope. So you're subtracting the y value at a point, at a time, minus a y value at another time, okay, divided by the x value at that time, minus the x value at another time. So if we look at this, right, we want to find the average rate of change from 1 to 3. So we're going to look at the y value at the time where 1 second passed, and then we're going to look again at the y value when 3 seconds have passed. And you're going to find the slope between these 2 points essentially. So our first point is 1 comma 10, okay? So that could be our y1. So we have 10 minus, and here's our y2, or our second y value, which is 2.5, okay? And then our x value at our first y value is 1, and then our x value at our second y value is 3. So literally just find the slope between 1 comma 10 and 3 comma 2.5. The average rate of change is the same thing as finding a slope at the point where t is equal to 1 and t is equal to 3, okay? So let's go ahead and let's find this in our calculator. We can do 10 minus 2.5 divided by 1 minus 3, and that will give us negative 3.75, which is choice 2. All right, number 12 says Fred recorded the number of minutes that he read each day from Monday through Friday, and his results are shown in the table. Which correlation coefficient to the nearest thousandth, or what is his correlation coefficient to the nearest thousandth, and the strength of the linear model of these data? So essentially, we're gonna have to plug this into our calculator. It's the only way to solve this. So what we'll do is we'll go into stat, we'll go into edit, and now we have this list. So usually I'm gonna say that list 1 should be your x, which is your time. So this is your time, and your y is the actual variable that isn't time. So this is number of minutes read, and I want you guys to copy this table into your calculator. Literally go ahead in list 1, go from 1, press enter, 2, 3, 4, 5, and then do the same for the other list. So essentially, we've just told the calculator our entire table, and now we're going to ask the calculator to give us the correlation coefficient. But before we can do that, you need to make sure that your calculator is turned on to a specific setting. So if you go second and 0, make sure to turn diagnostics on. So if you scroll all the way down to where diagnostics is, which is over here, hit diagnostic on, bam, now it's on. So now that we have that setting turned on, we can go into stats, and we can go into calc, and then we can scroll down to linear regression, or linreg. We can press enter. And so if I look at this table, the only thing I need to focus on here is my r. The r, not the r squared, but the r is going to be the correlation coefficient, which is 0.9838. This rounds up to 0.94. So I know that choices 2 and 4 are wrong. And now, because this is the r squared value. So remember, the r is the correlation coefficient. And the right answer here is 1. If your correlation coefficient is really close to -1 or 1, that means it's strong. 0.984 is super close to 1, which means it's strong. Number 13 says, given f of x is equal to x squared, which function will shift f of x to the left by 3 units? So essentially, if you want to shift something to the left by 3 units, you're going to add 3 directly to x. So f of x plus 3. If you want to shift something to the right, you're going to subtract directly from x. So f of x minus 3. So this is for left, this is for right. If you want to shift something up by 3 units, you add outside of the x, or away from the x. So this would shift you up by 3 units. And if you have f of x minus 3, this would shift you down by 3 units. So if I have f of x, which is equal to x squared, and I wanted to shift this to the left, guess what? I need to put my shift in the same parentheses as my x. So this shifted to the left by 3 units would be f of x plus 3, which means that I would have to add 3 directly to x. So I wouldn't do x squared plus 3 because that's outside of a parentheses with x. I would have to actually do x plus 3 squared. So this would shift me up, but this would shift me to the left, okay? So x plus 3 squared is choice 4, all right? Number 14 says a class of 20 students was surveyed to determine the number of pets that each student owned, and the data are represented in the plot below, okay? So which statement about this data is correct? And this is that the median and the mode are the same, okay? So the mode is the most repeated piece of data, which in this case is 2. 2 has the most number of dots, which means it's the most common piece of data. The median is taken by crossing out each one of these points from the left and then from the right. Okay, so one by one, you just need to cross out 1 point on the left side and then 1 point on the right side. 1 point on the left, left, and then right, left, right, left, right. And guess what? You're left with 2 points which are in the 2 column. So 2 is the mode, it's the most repeated point, but it's also the point in the middle using that method, okay? So the mean, you would have calculated the mean by adding together all the points. So you multiply the title right here, 0, by the number of dots here. Okay, so you'd multiply 0 by 1 to get 0. You'd multiply 1 by 1, 2, 3, 4 to get 4. You'd multiply 2 by 1, 2, 3, 4, 5, 6 to get 12, so on and so forth. So you'd add all of these together, and then you divide them by 20 to get the mean, which is the average here. which was not 2. Number 15 asks us the range of f of x is equal to the absolute value of x plus 2 minus 5 is what? So let's go ahead and let's plot this out. So if I go y equals, and I go down to, and I hit math, number, and ABS, that's going to hit the absolute value button. And now I can plug in x plus 2 into the absolute value button, and then I could subtract 5 from here, and I could press graph. And right now I don't see a graph because I didn't reset my zoom. So if I go zoom and fit, this will fit the zoom to my line. Or if I go zoom and then standard, here I've now zoomed out, and turns out I didn't need to press zoom fit because I can already see my line. Now the range is what's going to describe all possible y values. So the y values are going to go up and down, right? So wherever there's a line, there's a y value. And what's important for us to notice here is that the graph kind of stops existing after this point. And I could prove it to you because if I decide to go ahead and zoom out, this line essentially never goes below that point, okay? Never. So what is that point? Well, we can go ahead and we can hit trace, and we can trace this point all the way down, and that point is pretty much negative 5, okay? So this is telling us that as we approach that point is pretty much negative 5, okay? So the lowest that this point ever goes is negative 5, which means that the range, which is talking about the y, not the x, so 3 and 4 should be taken out because they're talking about the x. The y, the lowest it can go is negative 5, and then it can go up forever. So the y just has to be greater than or equal to negative 5. That's going to be my range because that's the lowest that the graph goes. Number 16 asks us which equation is always correct. In this case, remember that when you're multiplying two exponents that have the same base, that's the same thing as adding their exponents. So a to the power of 3 times a to the power of x is the same thing as saying a to the power of 3 plus x because they're both raised to the same base. Okay, choice 2 is wrong because a to the power of 4 raised to the power of x is equal to a to the power of 4 times x, not plus x. Okay, choice 4 is also wrong because a to the power of x times b to the power of y, this only works when both of the bases are the same. So choice 3 has to be the correct answer. Remember that whenever you have an exponent being raised to another exponent, right? For example, ab to the power of x, right? Technically, the exponent of a and b are both 1. So this is the same thing as saying a to the power of 1 times x and b to the power of 1 times x, which is just ax times bx, okay? Another way you could have done this was you could have just said, hey, a equals to 2, or you could have said b equals to 2. And you could have just plugged in these values into all of these expressions, and you would have seen which one had 2 equal numbers on both sides, which would have been only 3. Number 17 says the formula for the area of a trapezoid is a equals 1/2 h, b1, b2. The height, h of a trapezoid, may be expressed as what? So essentially, they want you to take this formula, and they want you to get h alone, okay? So we can just rewrite this as whenever you see a 1/2 or 1/3 or a fraction being multiplied by a bunch of variables, you can just move the variables into the numerator of that fraction, okay? So this is the same thing as saying a is equal to h times b1 plus b2 over 2. So kind of ignore that fraction, replace whatever's in the numerator with whatever it's being multiplied by, which is h, b1, b2. And now what we can do? Well, now we can just cross multiply, right? We now have a fraction, a over 1 is equal to h times b1, b2 over 2. So we can multiply a and 2 together to get 2a, and we set that equal to 1 times h times b1 plus b2, which is, well, nothing changes, right? It's the same thing. So here, this is equal to h times b1 plus b2. Okay, now I want to solve for h. I want to get h alone. What's bothering h right now? Well, it's being bothered by this b1 plus b2. So if I divide both sides by b1 plus b2, this cancels out, and I'm left with h. So h is equal to 2a over b1 plus b2, okay? Number 18 says 3 functions are given below. Which functions have the same y-intercept? So when we're talking about the y-intercept is when the graph crosses over the y-axis. And what's important is the y-axis exists when x is equal to 0. So the y-intercept is when x is equal to 0. So if I look here, this is my x and this is my y. When x is equal to 0, oh, it's this point right here, right? So over here, when x is equal to 0, y is equal to 3. Sorry, negative 3. So the y-intercept here is negative 3. Now I can find the y-intercept by just plugging in x equals 0 to both of these functions. So g of 0 is equal to 0 minus 3 squared minus 4. So 0 minus 3 is negative 3. Negative 3 squared is 9, and 9 minus 4 is 5. So the y-intercept here is 5. Over here, it's telling us the negative absolute value of 0 plus 2 plus 7. So in this case, the absolute value of 0 plus 2 is 2. Then there's a minus sign that we just slap on, and we're adding this to 7, and this is going to give us 5. So the y-intercept here is 5, the y-intercept here is 5, and the y-intercept here is 3. So which one of these equations have the same y-intercept? Well, that's g of x and f of x, okay? So g of x and f of x, choice 1. All right, number 19 says the sum of x plus 7 squared and x minus 3 squared is what? Okay, so we're just doing x plus 7 squared plus x minus 3 squared. So to do this, we can just expand both of these. So x plus 7 squared is the same thing as saying x plus 7 times x plus 7, which is the same thing if you multiply it out as x squared plus 14x plus 49. Okay, remember that a plus b squared is equal to a squared plus 2ab plus b squared. So in this case, x is the same thing, is going to be our a, so we just plug in x squared plus x times 2 times our b, which is 7. So that's where I got 14x from. We do the same thing here, just remember that a minus b squared is equal to a squared minus 2ab plus b squared. So now we're adding this to x squared minus 6x plus 9, okay? If you didn't want to remember this rule, you could have also just done it by hand, manually. So x times x is x squared, x times 7 is 7x, 7 times x is 7x, and 7 times 7 is 49. You would have gotten the same thing. But regardless, now we need to combine like terms. So here I have x squared, here I have x squared. X squared plus x squared is 2x squared. Over here, 14x plus negative 6x. Same thing as saying 14x minus 6x, which is going to be positive 8x. And over here we have 49 plus 9, which is going to be plus 58. So this is going to line up with choice 3. Number 20 asks us the product of 2 rad 10 and 3 rad 2 is what? So if I'm doing 2 radical 10 times 3 radical 2, I want to separate out the radicals from the coefficients. So 2 radical 10 is the same thing as saying 2 times radical 10. So let's just split them apart. And 3 radical 2 is the same thing as saying 3 times radical 2. So I want to split those two apart. I want to write the radicals together. So here I have radical 10 times radical 2. And here I have 2 times radical 3. Sorry, just 2 times 3. Those are my coefficients. So I multiply these two together, I write them separately, and then I multiply these two together, and I write them separately, okay? So radical 2 times radical 10, what's that equal to? Well, that's the same thing as saying 10 times 2 under the same radical, which is radical 20. So here I have 2 times 3 times radical 20. Okay, so this is what that turns into. Notice how that's not an answer, though. So we're going to have to simplify this, okay? But remember that if you have radical a times radical b, that's the same thing as saying radical a times b. So you just bring them underneath the same radical. So now I have rad 20, but I can simplify this, right? The way you simplify a radical is you take away the perfect squares inside of it. So you think, well, what two perfect squares, or what perfect square goes into 20? Well, I have I have like 10 times 2. They're not perfect squares. I have, 4 times 5. 4 is a perfect square. So again, remember that rule. If I have radical 4 times radical 5, that's the same thing as saying radical 4 times 5, which gives me 20. But wait a minute. Radical 4, isn't that a perfect square? Well, yeah, it is, right? If I have radical 4 times radical 5, I'm not going to combine them under a parenthesis, under a radical sign and do 4 times 5. No, I'm going to simplify it. The square root of 4 is 2. So now I'm just left with 2 radical 5, okay? So is that the answer? No, because you're forgetting about this 2 times 3 that we set aside. So now I have 2 times 3 times 2 times radical 5, okay? And that's going to line up with 12 rad 5, okay? Choice 1. Over here, 21 asks us, when 6x cubed minus 2x plus 8 is subtracted from 5x cubed plus 3x minus 4, what is the result? So again, we are just going to have to simplify. So let's write it down. Let's convert English to math, right? So we have 6x cubed minus 2x plus 8, it being subtracted from 5x cubed. So we're going to have to write this down first. So here we have 5x cubed plus 3x minus 4. And then from this, we're subtracting, and we're going to write this in parentheses, 6x cubed minus 2x plus 8, okay? So now what are we going to have to do? Well, we have this negative sign here, and what that means is we have to distribute it. So we're going to multiply everything inside of here by negative 1. So this times negative 1 gives us negative 6x cubed. Negative 1 times negative 2x gives us positive 2x, and negative 1 times 8x gives us, times 8 gives us negative 8. Over here, there's nothing in front of this parentheses, no plus or minus sign, so we can just break it out and drop it down. So here I have 5x cubed plus 3x minus 4. Now I can combine like terms. So here I have 5x cubed, here I have negative 6x cubed. So that's going to give me negative x cubed. Here I have plus 3x, here I have plus 2x, so that's plus 5x. And here I have negative 4 minus 8, which is going to give me negative 12, okay? Which is going to line up with choice 3. All right, number 22 shows us 3 relations, which represent a function. So essentially, a function, every x input has one y output. So I should not see any repetitions of x. So here, the input of 0 has an output of 1. The input of 1 has an output of 2. The input of 2 has an output of 3. The input of 3 has an output of 4. Good. When they show it to you in this format, you're literally just scanning to see if there's repeated x values. So for example, if this was 0, 1 and then 0, 2, this would not be a function because the x is repeated. But in this case, the x is not repeated, so yes, this is a function. When you look at it in this format, you know it's a function because every single x just has one arrow coming from it. So if one of these x's had 2 arrows coming from it, this would not be a function. But in this case, it just has 1 arrow, so you're good. Over here, you want to make sure, when you're looking at a function like this, you want to make sure that there are no 2 black dots or 2 lines that are on top of each other. If 2 black dots are on top of each other, it's not a function. If 2 lines are on top of each other and you can draw a vertical line through them, that's not a function. So in this case, this is a function and all 3 of them are functions. You may be saying, well, aren't there dots? Well, guess what? The white dot means that there's no graph there, right? There's no point here. The black dot means that there's a point here. So if you saw 2 black dots, that would mean that the graph is here and you can connect them with a vertical line, which means they're not a function. But because we have an open circle here, technically the graph doesn't exist at this point. So us drawing a straight line down here doesn't touch the graph 2 times, it touches it once up here. All right. Moving on, 23 says the method of substitution was used to solve the system of equations. Which equation is the first correct step when using this method, okay? So substitution means you're going to plug something in or you're going to substitute something. So over here, it's easier to substitute y and x. So if I add y to both sides, I get that x is equal to negative 1 plus y, which is the same thing as saying y minus 1. So this would be our first step. X is equal to y minus 1. When you substitute, you want to make something in terms of x or y. So in this case, it's easier to rewrite this bottom equation because we won't have to divide. Rewriting this top equation would be difficult because all of a sudden you'd have to, add 7y and then you'd have to divide everything by 4. This is super simple because our variables have like all coefficients of 1, so there's no division required. We just have to add y to the other side to get x alone. So the first step in substitution is to get x and y alone. So 3 and 4 were automatically wrong, and 2 rewrote the equation incorrectly, okay? Number 24 says in 2009, Usain Bolt, who's a sprinter from Jamaica, set the world record in the 100-meter dash with a time of 9.58 seconds. Which approximate speed in kilometers per hour can be found using which conversion? Okay, so you want to find his speed in kilometers per hour. Now, whenever you have kilometers per hour, the per means that whatever's after the per goes beneath the kilometers, right? So if I have A per B, that is the same thing as saying A over B. So here I have km over h, okay, or kilometers over hour. That's my target units, okay? Right now, I have a speed in meters per second, right? So I have a speed in m over s. So I want to go from m over s into km over h. And it's really simple. I just have to select the choice which properly cancels out units. That gives me kilometers on top and hours on bottom. So if I look at this, wherever you see a unit on the top and on the bottom, you can cancel it out. So for choice 1, I have seconds on the top here, I have seconds on the bottom here, they cancel out. I have meters on bottom, meters on top here, minutes here, minutes here. So now that I canceled everything out, let's look at our units. So here I have hours divided by kilometers, or h over km. I wanted the other thing around, right? Or I wanted it the other way around, so this is false. This is not the correct answer. Over here, if I look at choice 3, meters and meters cancel out. Seconds don't cancel out, okay? And nothing else minutes and minutes cancel out. So here I have kilometers times hours over second. Again, that's wrong. So here I have meters canceling out with meters. I have seconds canceling out with seconds, minutes with minutes, and my 2 units are kilometers over hours. So this is the correct answer. Right, so that's the end of this section. If you have any questions, feel free to let me know in the comments below. If you like this video, feel free to leave a like. And if you want me to continue going over this video, check out the videos if you want me to keep going over this exam, check out the videos I've uploaded. They go over the rest of this exam.